Welcome to Algebra 1, Unit 6, Lessons 9 and 10, Practice Problems. Write each quadratic expression in standard form. Draw a diagram if needed. I'm not going to draw a diagram. I'm just going to use FOIL. X times x is x squared. X times negative 1 is negative x. 4 times x is 4x. And 4 times negative 1 is negative 4. Now I add like terms. Negative x plus 4x becomes 3x. And the final answer is x squared plus 3x minus 4. Number 2. 2x times 3x is 6x squared. 2x times negative 1 is negative 2x. Negative 1 times 3x is minus 3x, and negative 1 times negative 1 is positive 1. Now we combine like terms, and negative 2x minus 3x is minus 5x. Our final answer is 6x squared minus 5x plus 1. Consider the expression 8 minus 6x plus x squared. Number 1. Is the expression in standard form? Explain how you know. Yes. Standard form is ax squared plus bx plus c. I can rewrite this expression as x squared minus 6x plus 8, where a equals 1, b equals negative 6, and c equals 8. Number 2. Is the expression equivalent to x minus 4 times x minus 2? If we use the distributive property, or FOIL, x times x is x squared. X times negative 2 is minus 2x. Negative 4 times x is minus 4x. And negative 4 times negative 2 is positive 6, or positive 8. Now if we combine like terms, we get x squared minus 6x plus 8, and that's exactly what we just had. So yes, it is equivalent. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. Which quadratic expression is written in standard form. Standard form is ax squared plus bx plus c. The only one that is written in this form is c. A equals -1, b equals -5, and c equals 7. A is in factored form, b is in factored form, and d is in partially factored form. If you have any questions about identifying standard form quadratic expressions, please use class time to ask for further clarification. Explain why 3x squared can be said to be in both standard form and factored form. Well, standard form is ax squared plus bx plus c. Here, a equals 3, b equals 0, and c equals 0. So if I plug 0 in for b of x goes away. And if I plug 0 in for c goes away, and I'm just left with 3x squared. So this is in standard form. Factored form is two linear terms multiplied together. Three x squared equals 3x times x. So this could be seen as a factored form. If you have any questions about standard form and factored form quadratic expressions, please use class time to ask for further clarification. A quadratic function f is defined by f of x equals x minus 7 times x plus 3. Number 1. Without graphing, identify the x-intercepts of the graph of f. Explain how you know. X-intercepts have a y value of 0. To multiply two numbers and get 0, one of the numbers must be 0. So either x minus 7 equals 0 and x equals 7, or x plus 3 equals 0 and x equals -3. So my x-intercepts are 7, 0, and -3, 0. Number 2 wants us to expand x minus 7 times x plus 3 and use the expanded form to identify the y-intercept of the graph. So x times x is x squared. X times 3 is 3x. -7 times x is minus 7x. And -7 times 3 is -21. Combine like terms, and we have x squared minus 4x minus 21. Y-intercepts have an x value of 0. So f of 0 equals 0 squared minus 4 times 0 minus 21, which equals -21. So my y-intercept is 0, -21. If you have any questions about how to find x-intercepts or y-intercepts, please use class time to ask for further clarification. What are the x-intercepts of the graph of the function defined by x minus 2 times 2x plus 1? So remember, x-intercepts have y equals 0. That means x minus 2 equals 0, or 2x plus 1 equals 0, because I'm going to multiply two numbers and get 0 as an answer, so one of them must be 0. Here I would add 2 to both sides, and x equals 2, or I subtract 1 from both sides, 2x equals -1, then I divide both sides by 2, and x equals -1/2. So now I look at my points, and b gives me 2 and -1/2. Either of these will make this first one 0 or the second factor 0, and 0 times anything is 0. So A does not work, C does not work, and D does not work. If you have any questions about how to find x-intercepts, please use class time to ask for further clarification. Here is a graph that represents a quadratic function. Which expression could define this function? Well, in order for me to find my x-intercepts, x-intercepts have y equals 0. So that means this point right here, I have x-intercept of -1 and an x-intercept of 3. So I need to be able to put -1 into one of the factors and have it become 0. So if I have -1 plus 1, that equals 0. If I have -1 minus 1, that equals -2. So I cannot have -1, so it's not B and it's not D. Then if I have 3, 3 plus 3 would equal 6, but 3 minus 3 would equal 0. So I could not have x plus 3. So the only one where both factors would give me the x-intercepts that I see on the graph, the answer must be choice C. If you have any questions about how to find the expression by using the graph, please use class time to ask for further clarification. What is the y-intercept of the graph of the equation y equals x squared minus 5x plus 4? So remember, y-intercepts have x equals 0. So y equals 0 squared minus 5 times 0 plus 4, which equals 4. So the y-intercept is at 0, 4. Number 2. An equivalent way to write this equation is y equals x minus 4 times x minus 1. What are the x-intercepts of this equation's graph? Remember, x-intercepts have y equal to 0. So either x minus 4 equals 0. We could add 4 to both sides, find out that x equals 4, and our x-intercept is 4, 0, or x minus 1 equals 0. We could add 1 to both sides, find out that x equals 1, and our x-intercept is 1, 0. By using either of these x values, they'll make one of the factors 0, and 0 times anything equals 0. If you have any questions about how to find y-intercepts or x-intercepts, Please use class time to ask for further clarification. Noah said that if we graph y equals x minus 1 times x plus 6, the x-intercepts will be at 1, 0 and negative 6, 0. Explain how you can determine, without graphing, whether Noah is correct. Well, x-intercepts have a y value of 0. So, either x minus 1 equals 0, we add 1 to both sides, and we find out x equals 1, so our x-intercept is 1, 0, which matches what Noah said, or x plus 6 equals 0, we subtract 6 from both sides, x equals negative 6, and our other x-intercept is negative 6, 0, which matches the other answer Noah gave. So Noah is correct. If you have any questions about anything we covered on these practice problems for lessons 9 and 10, please use class time to ask for further clarification.